Welcome back to another video. Today I wanted to talk with you about direct and indirect heat when it comes to microsoldering. So let's get into the video. There are many different cases where you should use direct heat versus indirect heat when working on electronics. Certain types of connectors, certain types of plastics will melt under direct heat. So in order to install them, you need to do it with indirect heat. For example, an easy one would be a SIM card reader on an iPhone motherboard. Direct heat would definitely melt the sensitive plastics inside the connector. So although you can remove a damaged SIM card reader with direct heat, you would never want to install one with direct heat. You'd want to go with indirect heat. And what I mean by that is applying heat to the opposite side of the logic board, and the heat will transfer through and melt the solder that's on the other side of the motherboard, allowing for the contact points to make solid solder connection, solidify, and function as desired, versus doing, say, a NAND swap on a motherboard to increase its memory on, say, an iPhone. You'd want to apply a direct heat to the NAND. Otherwise, you're going to be damaging the motherboard, because on the opposite side typically sits the CPU, and you don't want to heat that up. So you can't apply indirect heat from below to melt the solder under the NAND. You'd want to heat the NAND directly itself to help prevent too much heat from going all over the motherboard. Or for example, yesterday we worked on a Samsung motherboard that needed a new battery connector, and you'll have noticed that direct heat was applied to the connector. Obviously the connector is made of plastic and metal, and the metal's not going to melt, but the plastic can. And so understanding temperature control, airflow, and flux, and the type of solder really helps make a job like that go smooth, so you don't actually end up burning the plastic, making your job harder. Now, you've seen me in the past do videos on, say, an HDMI on an Xbox or a PlayStation, where I'm using indirect heat through the bottom of the motherboard to solder a new HDMI. And then I go and I touch it up with direct heat using, say, a soldering iron to make sure the pins are all good. And the same goes for a charge port on, say, a Nintendo Switch. However, if you're working on the charging IC on a Nintendo Switch, you need to use direct heat to remove and replace it. Today I will show you another example. I'm going to be using this LG. This is a motherboard for an LG ultrafine display, one of those high-end displays. It has two USB Type-C connectors that have sheared off the motherboard. It's a very common issue on this motherboard, and there are several instances where I will be using indirect heat and direct heat. So we'll get into that. Reasons for that are obviously, am I going to be affecting surrounding components with direct heat? For example, this plastic connector here on the corner will melt easily with direct heat. So I can either shield it or I can remove it while I'm working next to it. And when it comes time for me to install the USB-C ports, is it going to be better for me to use indirect or direct heat? Comment down below what you think, and we'll see if you're right. So what I'm going to do now is come in from above to remove the plastic port on the bottom of the board. By applying indirect heat, I'll be able to melt the solder so I'm not actually burning the plastic, and I'm able to successfully extract the connector so that I don't burn it in the next step of replacing the actual ports themselves. The one that I removed has through-hole technology, which means it's really easy to solder back on with a soldering iron, versus the two Type-C USBs. They are hidden solder joints, meaning I can't actually use a soldering iron to tack each one of these pins, so I have to use hot air to do that, but I also can't use direct hot air, otherwise I will melt the plastics. So I need to use indirect heat by going from the bottom. However, before I get to that, I will be using direct heat to help remove the old solder and replace the solder with new fresh solder by using my hot air rework station to help heat up and properly spread new solder paste over all of the pads, including the through hole joints that will secure the port in place. Now that that's all set up and ready for me to install the ports, I will then transfer the heat through the bottom of the motherboard till the solder melts on the top, allowing me to compress a new port down through. Now you can see that I'm using plenty of flux to help install these ports. And one big tech tip is to pre-tin the pins on the bottom of the USB-C port. This ensures that the solder does in fact leach from the pad to the pin on the connector. Once I've installed both of these connectors and everything looks good, I can then go and solder back on the first connector that I removed with a soldering iron. Make sure those joints are solid, and this motherboard can be installed back inside the monitor and be used again. And those are some of my tips and tricks on using direct or indirect heat when it comes to microsoldering. If you have any questions, leave them in the comments below. If there's something that you'd like to see in a future video, let me know as well. Or if there was anything that you would have done different, comment it down below. And I look forward to reading those comments. Thanks a ton for watching. We'll see you in the next video.